Bismillahirrahmanirrahim. So we were talking about distributed computing because what we said is because we want to arrive to cloud computing. Basically, what we want for IoT, cloud computing for IoT. This is the crux. This is what we want to accomplish here. So we said firstly we had a standalone systems. In standalone systems we had everything there, right? So we had everything on a single system. So whether it is interface, or it is computing, it is database, whatever it is, it's all in the one. So we try to create a mainframe computer, the big computers, but then we see that it fails, okay, and it doesn't have those features we want. In IoT, we can't do it because the devices are all over the place, so we cannot connect them to the one system only. So there are a lot of issues where IoT may not work. What happened to this? What? Why is it okay? You have used the screensaver on this? Anyways, so in IoT we can't even think about it, and there are a lot of computations to be done which cannot be done by the mainframe. So we have to do something. We have one job. We want to break this job into multiple processes, okay, and we can give them to different units, okay, to give them different units, different computers or whatever they are, to do. They all work in a tandem to do one job. Like I gave the example of Osman yesterday, right? Or you could have something else. So we are trying in a distributed computing. What we did in 1940s, it's an old story, and today the cloud computing is actually the same. We do different things, which is actually having all the features. The cloud computing is having all the features of whatever we have learned and evolved over the distributed systems. So technically speaking, it is that we want to divide our job into multiple jobs, sub jobs, and give it to multiple units, okay, and they, without the knowledge, the user doesn't have the knowledge what's happening on the back, and they all work together to accomplish that job. Now this job, multiple jobs can be given to multiple computers depending upon the load. If this computer is having more load, so we will not give this job to this, we give to this one. So we will see which peripheral, which device we have on the back end which is free, which is have, so we have a load balancing and all. So that means we will have some kind of softwares running on a backside, some kind of a software management systems which manage these all things, which schedule. We call them as a scheduler. Mostly we schedule those things, right? And then the distributed computing happen to be of variety of things, variety of paradigms at distributed computing got. But the crux, the root is distributed computing, the standalone and distributed computing, right? And then we have read a lot of things yesterday. That video is also coming on a YouTube. Is it not? Okay. Now the one of them is the cluster computing. One of them is what? One of the examples of distributed computing. One of the ways, the paradigms we have in the distributed computing is the cluster computing. In cluster computing, basically, if you could see this is the rack. I got the picture here. This is the rack, okay. This is the rack. This is a rack inside them. As you could see, these are the racks. There is no display system and all that. These are all computers, all bunch of them, lots of them. There are lots of computers, and they are homogeneous. That's the difference. They are what? They are same computers, and they can be assigned to do particular job. So we want to have some job, we'll break them into sub processes, and those jobs can be given to these computers, okay, but they are homogeneous. They are what? So this is the most important thing. So it is a group of tightly coupled. This is a technical term. Tightly coupled is a loosely coupled, okay. It's actually about the memory. So wait a while for this. Working together as a single system. So they are working together as a single, but there are lots of computers, okay, and these are homogeneous systems, high speed interconnected, used for parallel processing. So, and we can have a use cases from them. And if you could see here, we have, these are the clusters, we name them, and we have the head node. Well, this is a spatial computer which actually is connected with the internet, which actually then assigns the job. But this is not the guy who assigns the job, it's a scheduler, like for example the grid engine, or previously called as dynamic resource manager, which manage the job to these. So we have to say, like I said, that we have a job and we break them into the sub jobs, and we give these sub jobs to the computer, and we see which one is having less load, we give it to that. For example, this is already doing some job, we will, or this may say wait, put up some queue if we are already busy and all that. So it is the job of the head queue to connect and sum up all that thing, then give it to the internet and back to the IoT device or something else, where from which wants that service. So again, it's a grid computing. Sorry, this distributed computing, but it's a different version where all clusters are homogeneous. That is the thing. They are what? And it's not about this is the having display system and all. These are only processing and with some storage and data storage. They have storage and their processors and RAMs and all that. Okay, but they are working. For example, we have to paint the car. Now what we do is we have one painter. He will do painting here. Bumper. No, we do one thing. This paint job is divided into multiple jobs, like paint bumper, paint bonnet, paint dicky, paint top, paint side, paint left window, paint right window. So I got 20 people. Okay, and then paint job. They go on bingo, do it 5 minutes, done. Right? So if the single processor was doing it, it will take a lot of time, right? So now we have the multiple processors working together. It's sometimes also called parallel processing, but parallel processing is a different paradigm. Okay, it has little different technicalities. You got that? So this is the job script. So how many, what will the scheduler do? How many CPUs you want? How much memory? How much time? Will be decided by the scheduler, right? Because it schedules the jobs. Where from we got the jobs? We divided our primary job into multiple jobs. Okay, and done. Head node is a special cluster, the same computer, but who is like a monitor. Like you have a CR, you're all same, but the CR is a connection with the office and all, right? But it's the same student, right? But she is little, which is connection with this has got the connection with the internet. And that means the job comes to the cluster via the head node, and head node has the softwares and all which assign the jobs to the other computers, right? Exactly. It's the same. These are also nodes, but it's called a head node. But it has the extra job of scheduling and all managing things, right? Like it's kind of an admin of these clusters. Got it? But it's again a computer, right? It's not somebody else. Now, as you can see, this is another version of it. These are the clusters. There's Ethernet switch. You must have worked out the example. I told you how was the router switch. Have you done that?
Yes, sir.
I will see the copy and concept from Monday. You guys have to speak up. But I have in this lecture, I want to have one more thing I have to do is about the hardware of IoT, like sensors, microprocessors. What is the difference of microcontroller, microprocessor, and what is Arduino? What is our Raspberry Pi? What's the difference between them? We have to add that to the lecture to this. But first we understand the cloud architecture, like fog and edge, distributed computing and all. So you should today at least have a clear idea between cloud, fog and edge, which we need for the IoT. Okay. Now next we have the hardware. We need to understand the hardware used for the IoT. That will be our next session. You getting this point? So these are the clusters, this is server and all. This is same what I talked about. So now another version of the distributed computing is the grid computing. The difference between the cluster and the grid is, in the cluster we had homogeneous computers, right? In the grid we have heterogeneous computers. They are somewhere else. Again, they may be in a cluster. Okay, multiple computers to solve large scale computational problems, right? So these computers can be across the geographical area. They can be anywhere. Okay. In cluster, we are creating. This is a building, and we have one clusters of computers which is working with. We are working with it. Okay, and we are assigning the jobs to it. But in grid, we have computers all over the geographical place, and they are independent computers. They are heterogeneous. They may have different operating systems. This computer has a different operating system. Another computer has different operating system. They are working in a Linux domain. They are working in the Windows domain. They are working in other domain, right? Platforms, some other platforms. But they are used, again, my job, and I divide into sub jobs, and these sub jobs are given to these computers. They give me the solutions. For example, I do data analytics. I have to do, because if you say IoT, what's happening in IoT, the huge amount of data is coming up, okay, and we have to do maximum time the data analytics, and the data analytics is being done by those computers. Now I'm not doing it on a cluster, I'm doing it on a grid. Got it? Yeah. Now look at that, read that. What is the need for grid computing? What is the underutilized resources? Because we may have the computers, and which computer is actually having less job, we balance the load and we utilize that, okay. And visualizing for scientific problems become complex, and user need more accurate and precise solution. That cannot be done by the single computer and all. We need a multiple computers to simultaneously work on it, right? That is why we need a grid computing. Like we have weather forecasting, detection and modeling natural disasters. It can't be done like that. No, you have a computer here. If you do weather forecasting, you need computers all over the place. It should watch over the all India and all, for example, to speak about if I want to see weather of the Kashmir. So we have to have data from all the sites to understand the wind and the clouds and then we can predict. It's not an easy job. So we cannot do the one computer on a building and having sensors and all can do this job, man. We have to have whole area. So it has to be a grid. It has to be there has to be the grid computing which can do that, right? And etc. etc. Now this is, for example, electric power grid. You got the plug, you put it in, you get the electricity. You don't worry about, as a user, don't worry where from the power has come, but it has come through the grids. There are tons of grids where the power has come. There are tons of people. If you see the Islamic college, and there on the floor, on the all top is generating their solar energy. It is giving to the grid. Today, everybody is going for the solar panels, and solar panels they are on grid solar panels. They are not storing on the battery. They are sending it to the grid. They are sending it what? तो जो इलेक्ट्रिसिटी यहाँ आपको आ रही है ना, इट कुड बी योर नेबर्स सोलर पैनल, यू डोंट नो ये कहाँ से आ रहा है. गेटिंग? कि जैसे मैं अभी लगाने वाला हूँ अभी सोलर पैनल, वो मैं ऑन ग्रिड लगाने वाला हूँ, लेकिन जो भी मेरा इलेक्ट्रिसिटी जनरेट होगी ना, इट विल बी गिवन टू द ग्रिड, राइट? एंड इट इज द ग्रिड हु इज गेटिंग ऑल दीज थिंग्स एंड देन गिविंग यू द इलेक्ट्रिसिटी, बट यू नेवर नो कि ये कहाँ से आया. You have a socket, you put it in, you got the electricity, you are solved the solution, but ये कहाँ से पीछे से आ रहा है? It has gone from the multiple grid stations. That's why we call them a grid station, right? User get access to electricity through wall socket with no care of whatever. So जो power grid है, links power plants of different kinds. कोई hydroelectric power plant है, कहीं से solar electricity आ रही है, solar से power आ रहा है, कहीं से पता नहीं कहाँ से आ रहा है, and it combines all of them, right? Same is with the grid. तो आपको कंप्यूटिंग रिसोर्सेज मिल रहे हैं, आपका प्रोसेसर मिल रहा है, स्टोरेज मिल रही है, डेटा एप्लीकेशंस मिल रहे हैं जब आपको जरूरत होगी, लेकिन आपको नहीं पता कि वो कहां से आ रहे हैं, आपको नहीं पता वो किधर से आ रहे हैं. द ग्रिड मैनेजेस इट. जो ग्रिड होता है वो लिंक करता है कंप्यूटिंग रिसोर्सेज एंड प्रोवाइड्स मैकेनिज्म टू एक्सेस देम, है ना. तो हमने पूरी ज्योग्राफिकल एरियाज में कहीं पर भी वहां से कंप्यूटर्स हैं, वहां से रिसोर्स हैं, वहां एप्लीकेशन से ला रहे हैं, वहां डेटा स्टोरेज है, आपको मिल रहा है एज ए यूजर, आपको चाहिए, आपको मिल रहा है, बट यू नेवर नो कि कहां से आया. ग्रिड मैनेजेस इट. सो दैट्स व्हाई वी हैव द स्पेशल softwares and all to manage the grid.
So you said
yes.
grid के कनेक्ट करेंगे तो वो वहां से और हमें भेजेंगे, फिर उसके बाद तो फिर
मैं समझा नहीं, फिर से बताओ.
जैसे आपने बोला था सोलर वाला, ठीक है, तो वो पहले ग्रिड को भेजेगा, उसके बाद वो हमें आएगा.
उसके बाद आपको नहीं आएगा, फिर वो कहां से आपको आ रहा है आपको नहीं पता. लेकिन अगर आप स्टोर करना चाहते हो, जैसे आपने एक बनाया, आप स्टोर करना चाहते हो, मे बी यू डोंट यूज दैट एट दैट टाइम, है ना, आपको बेनिफिशियल, बिकॉज जो आपको जनरेट कर रहे हो उसके तो आपके पैसे मिलेंगे ना, जो आप जनरेट कर रहे हो. सो जब आप, अब वो ऐसे पैसे नहीं देते, जब आप यूज करते हो तो उसमें से आपको वो कट जाते हैं, और अगर आपका बच गया, मे बी विंटर्स में आपने ज्यादा इस्तेमाल किया, तो फिर वो आपके जो यूनिट जमा हो जाएंगे ना वहां, तो वो वहां पे विंटर्स में कटेंगे. जैसे समर्स में आपका ज्यादा इलेक्ट्रिसिटी जनरेट कर रहे हो, इस्तेमाल उतना नहीं कर रहे हो, लेकिन विंटर्स में ज्यादा इस्तेमाल कर रहे हो, सो लेकिन उसमें अपनी चॉइस भी रहती है कि यू कैन स्टोर दैट आल्सो, बट दैट्स नॉट बेनिफिशियल. ओके, गॉट इट. सो क्लस्टर में मैंने एक डिफरेंस क्या कहा था, वी हैव होमोजेनियस कंप्यूटर्स, हियर वी हैव सिमिलर ऑपरेशंस. अनयूज्ड प्रोसेसर्स में सिमिलर ऑपरेशन की जरूरत नहीं है, क्लोजली लोकेटेड, फार अवे, है ना. हाई स्पीड लाइन, इसे इंटरनेट चाहिए होगा, उसमें तो लैन चाहिए होगी ना, क्योंकि वो, हाँ, क्लस्टर आपके कंप्यूटर कंपनी के अंदर है, तो आपने वो प्रोसेसर इस्तेमाल किए हुए हैं, लेकिन ग्रिड तो कहीं पर भी हो सकता है, इट कैन बी एनीवेयर. ओके, ये सेंट्रलाइज्ड है, इसमें डिस्ट्रीब्यूटेड है. सेंट्रलाइज्ड स्केड्यूल एंड डिसेंट्रलाइज्ड, एंड यू कैन रीड दैट. ओके, the never next is the utility computing, because cloud computing is one step ahead of utility computing. This is the utility computing जो हमारी है, it is again the type of distributed system, right? So distributed computing, sorry, जो distributed computing हमारी है, जो आपका utility computing है, again we said cluster, we said grid, and now we have the utility. जो utility computing है उसमें क्या हम करते हैं, we pay as you go. That means जैसे आपकी पहले आती थी आपको केबल, आपको उसमें 200 चैनल्स आते थे, व्हाटएवर, आपको पे करना पड़ता था 200-250 रुपए. लेकिन अब आप बोलते हैं आपको आपको ESPN देखनी है, आपको कौन चैनल देखने हैं, जो चैनल देखनी है उसी के पैसे भरो. यानी कि आपको कौन सी एप्लीकेशन जरूरत है. फॉर एग्जाम्पल, मैं कहता हूँ मेरी कंपनी को, भाई मेरे को प्रोसेसिंग पावर बहुत ज्यादा चाहिए, ठीक है, तो मेरे को प्रोसेसिंग चाहिए, ठीक है, और मैं कहता हूँ भाई मेरे को एप्लीकेशन जरूरत है, मुझको फोटो एडिटिंग करनी है, मुझको सिर्फ फोटो ऐप दे के दे दो. सो जो आपकी मर्जी है, जैसे आप कहते हैं मुझे ईमेल सर्विस जरूरत है, तो आपको ईमेल वाली ही सर्विस दी जाएगी. सो दिस इज पेपर सर्विस. पेपर जो गूगल सर्विसेज हैं वो मैक्सिमम फी फ्री है, बहुत सारे उसमें पेड भी है, लेकिन मैक्सिमम आपको दी जाती है ना फ्री आजकल, है ना. आपका जीमेल हो गया, आपको स्टोरेज दी जाती है. आप व्हाट इज द जीमेल, इट्स अ काइंड ऑफ एन एप्लीकेशन, राइट, व्हिच यू कैन यूज. गूगल डॉक्स आपके पास है, सो वो एप्लीकेशन आप इस्तेमाल कर रहे हो ना. So this is called, that is the utility computing. Then that means you are using this as a utility, right? और जब आप चलोगे इसके आगे, तो फिर हमारे पास है डेटा सेंटर्स, यू नो, मैक्सिमम एरिया विद डेटा सेंटर्स, राइट. सो व्हेन कंप्यूटिंग एक्सीड्स कंप्यूटिंग रिसोर्सेज, देयर आर टू ऑप्शंस. क्योंकि आपको अगर कंप्यूटिंग की ज्यादा जरूरत है, या तो आप स्केल अप करो, वर्टिकल स्केलिंग, यानी कि आप इंक्रीज रिसोर्सेज ऑफ इंडिविजुअल सर्वर, जो आपके घर में सर्वर बैठे हैं ना कंपनी के, वहां उसको इंक्रीज करो. या आप क्या करो, डिस्ट्रीब्यूटेड कंप्यूटिंग, जिसमें आप स्केल आउट करो. स्केल अप नहीं, स्केल क्या करो, यानी कि हॉरिजॉन्टल स्केल करो, आप नंबर ऑफ सर्वर्स इंक्रीज करो, आप नंबर ऑफ. सो डेटा सेंटर्स वो है स्केल आउट करते हैं. दे डेटा सेंटर्स आर हैविंग लॉट्स एंड लॉट्स ऑफ सर्वर्स, राइट. जैसे फेसबुक है, नाउ यू कैन इमेजिन जो फेसबुक आपको है, इट्स हैविंग, इट्स नॉट अ स्मॉल kind of a software only which is on your phone. Whole planet is on Facebook, everybody is using Facebook. See how much data they have. मेरे सारे फोटोज, जब से मैं तकरीबन पैदा हो गया तब से मेरे फोटोज, मेरे पोस्ट्स, मेरे पता नहीं क्या क्या, ठीक है, और ऑन फेसबुक. मैं नहीं बंदा, पूरा दुनिया, population of whole world I think is on Facebook. So imagine how much data they have and how much processing they has done. And see the beauty of this architecture कि आप Facebook खोलते हो and you don't, it never stops. यूनिवर्सिटी की हमारी साइट होगी, उसको चंद बंदे एग्जाम का होता है, खुलती नहीं है साइट. जगह वो उसका रिजल्ट होता है, वो साइट खुलती नहीं है. क्यों? दे आर नॉट लाइक दिस. दे आर हैविंग सर्वर्स, simple servers at the home, maybe cluster, they may have little cluster which is working on them. Even they may not be having the distributed computing, they have the simple computing, while we have big server, okay, which is working, which gets bogged down easily when there is a load. Imagine Facebook, कितने users Facebook के पास, कितना सारा data है. Have you ever seen any delay and everything in a Facebook, right? Even we are going on calls now, right? Calls भी होते हैं, video calls भी होते हैं Facebook के ऊपर, and there are tons of things happening. And उनका analytics भी आप देखो, उनका जो आपको, आपने एड देख लिया वहां से मिंत्रा से, और फेसबुक आपका रीड कर रहा है कुकीज, एंड वो फेसबुक थ्रोज द सेम एड्स. जैसे मुझे एक बोल रहे थे, ये दिमाग पड़ता है, पता है आपको, मुझे पता रहता है कि फेसबुक दिमाग पड़ता है, कैसे पड़ेगा यार दिमाग. देखा, मैं जो सोच रहा था ना एड, वही आ गया. मैंने कहा वो नहीं सोचा तूने, मिंत्रा पे कहीं पे देखा होगा ये वो फेंक रहा है. इट्स एक्चुअली कॉल्ड, यू नो, फेसबुक इज कॉल्ड, इट्स एन एक्सटेंशन ऑफ योर ब्रेन. नाउ अगर मेरा मोबाइल फोन आप देखोगे ना, इसमें आपको यही चीजें मिलेंगी. जैसे कोई मौली साहब आएगा, वो वाज भरा, या ये क्या एआईएस मतलब कहाँ चीज. जैसे मैं आजकल ज्यादा आई हैव स्टार्टेड, यू नो, टीचिंग कुरान एंड ऑल. सो उसमें मैं थोड़े वीडियोस बना रहा हूँ ना बच्चों के लिए अच्छे से, बिकॉज आई हैव माय किड, एंड सो आई created a course for that. When I was parents, because in my school ना जिसको वहाँ these parent association I'm heading that, so वहाँ पे मैं अब मैंने कहा पेरेंट्स को, अब पेरेंट्स भी आ गए, तो अब मुझे अगर फेसबुक देखो ना तो वहां पे आप एनिमेटेड, अगर मेरा आप ये खोलोगे इंस्टा, इंस्टा में आपको मिलेगा कि कोई एनिमेटेड वो बोल रहा होगा दुआ एंड ऑल, क्योंकि मैं उसी के ऊपर काम कर रहा हूँ आजकल। गेटिंग? सो जो जिस किस्म का बंदा होगा, अगर आपको देखना होगा ना आजकल की बंदा कैसा है, ठीक है, ओपन अप हिज फेसबुक एंड ऑल इंस्टाग्राम, जो उधर आता है तो वो वैसे ही बंदा है। गेटिंग माय पॉइंट? सो इट इज द एक्सटेंशन ऑफ योर ब्रेन नाउ, you understand? So, and you see the data center, it is because of the data center, the big data centers where we have the big servers and we have scaled out. हमें लग रहा है कि लोड और बंदे आ गए, लगाओ एक और सर्वर, because it is scalable. It is what? This architecture is scalable. जितना लोड आ गया उतना आप इसको vertically नहीं horizontally extend कर सकते हो। vertically का मतलब होता है, दैट स्केल इन का मतलब होता है कि आप एक ही सर्वर को बड़ा बड़ा कंप्यूटर लगा रहे हो। अब हम ऐसा नहीं करें, हॉरिजॉन्टल इसको स्केल अप कर रहे हैं, उसका मतलब है कि एक सर्वर आ गया फुल, लगाओ दूसरा सर्वर, लगाओ दूसरा सर्वर, लगाओ तीसरा सर्वर, एंड सो ऑन। गेटिंग? So this is the Google data center. This is the inside the Google center. If you could see, there are tons of servers and these machines working together, and they are not like computers, like we have a display and all. They are processors, okay, loaded with the processing power and storage. And for storage they have the database, data stores, which are huge databases, right, and all that. Now when we talk about all these things, now we go step up from the utility computing. We want to have everything as a utility now. See, if we want to say what is cloud computing, it is again the type of distributed system. The root is same, the concept is same, distributed system, but we are doing what? We are putting everything as utility. You want processor, put it as utility. You want storage, put it as utility. You want application, put it as utility. Right? This is what cloud is. And that is why this guy, Larry Ellison, he said it is nothing new. It is same old story. Okay? Everything that we already do, that means what we already do as a distributed computing, it is same as that. That's why he's saying, I do not understand what we would do differently, other than to change the wording of some of our ads. That we are changing from distributed system, they call it cloud computing and all the jargons, new jargons. So it's actually the same. It's actually what? But actually, technically speaking, cloud computing is putting everything as a utility. You can see this, put this thing in your brain. It is putting everything as what? Utilities. Everything as paper service, or everything what you want, and we will give you. So delivers computing services over the internet. First thing, there should be internet. You are working on the internet. Okay, and when you say IoT, again, it has to be internet in it, right? We are not doing it, like a smart device and all. I told you what's the difference between smart device and IoT. I told you in the first day. So on demand, self-service, broad network access, resources pooling, rapid elasticity. यानी कि आप इसमें आप पूलिंग कर रहे हो रिसोर्सेज की, आपको स्टोरेज चाहिए, प्रोसेसिंग पावर चाहिए, whatever you want, it is to be scheduled whenever you want. Okay, so whenever you want, you can get it. That's the cloud, and everything is now cloud, right? So if you see the Google services, they are on cloud. You are using tons of services of Google. You are using Google Photos, you are using Google Drive, there is Dropbox. On the Google, there are Google Docs, Excel sheets. No, everybody working on the cloud these days. So you want an application. I want to write something. You go Google Docs, you put up the, okay, like a Word, you write, or Google Sheets. You want to have an Excel. So app is given. Sometimes you want a processing. I know, like IoT devices, they are using a lot of data, right? And who is doing analytics? The computers can't, the simple computers cannot do the analytics. They are highly intensive. And the IoT devices, they have like Arduino chips and small chips, which cannot do that much of computing, right? So what will they do? They will send it to the cloud. And the cloud, the processing is being done, right? In the cloud, what is done? So it's a service model. So in the cloud, remember this thing, it's a service model. What is it? So there are typically three things. That's called infrastructure as a service, platform as a service. So we say SaaS, PaaS, and IaaS. SaaS, PaaS and IaaS. It's not SaaS, Bo and Wo like that. It's a SaaS, PaaS and IaaS. SaaS is the software as a service. This is, don't get bogged down. This is same that you want software, so we will give you as a service. ना paper service जो भी बताया, utility computing ही है ना ये. So platform as a service and infrastructure as a service. So three things we have: SaaS, PaaS and IaaS. और बहु पता है, वो मेरे को नहीं पता कहाँ है. So you can see this, okay? So software as a service. So write down this: SaaS, PaaS and IaaS. Work on it. I will not be telling too much about it. It's very simple, by the ways. So when you say software as a service, it will be technically the end user who will be using this software as a service. Where you have like Google Docs and all, Salesforce.com, you have you want to have some softwares and you want to access that, and they are on cloud, like you can visualize on the Google Docs, right? So you want to access them, so it can be given to you, right? So that is what SaaS means in the cloud computing. Now platform computing is where you will have the development environment. This will be the PaaS will be done by the developer. It will be mostly used by what? The developer, where they have the development environment and all that, right? So I will go quickly on this. You will work on these three things. This is today's assignment. In cloud computing, what is SaaS, SaaS and PaaS and IaaS? Okay. Watch a video on YouTube on it, make some note on it, like that, till the concept gets cleared. Then there is a infrastructure as a company, जहाँ पे आपके सारे resources, databases, operating system चाहिए होगा and all that. पूरा platform चाहिए होगा आपको, ठीक है? So ये सारे आपको infrastructure as a service में आ जाएगा, ठीक है? Now there are like, कोई बात नहीं, just give me 5 minutes, no problem. So in this case we have a special managers. For example, we have the storage, how to store data things. We have distributed file system, like we have Google file system or Hadoop distributed file system. Hadoop is maximum times we use in a cloud as a storage. We use what? Hadoop. Write down Hadoop and work on this also. What is Hadoop? What is Hadoop? Hadoop. And we have the Hadoop distributed file system which will be used. Okay. Now for the cloud computing for IoT, this is the last and crux of the lecture, right? Which we have which we were trying to work for. So this is what we have now. This is what we were working so far from 2 days. That is cloud computing for IoT. Okay. What is in IoT happening? Huge amount of data needs storage, retrieval and management. Not only storage, but retrieval and management. You also need to retrieve that data tomorrow, okay? And you need to manage it. You need to do data analytics also. You need to do analysis of the data so that you can take decisions, right, in IoT. So that cannot be done on the fast analytics for prediction, critical decision making. आपको prediction करना है, जैसे हमको predict करना है weather, ठीक है? Critical decision making, आप surgery कर रहे हो using the IoT, and you have to take decision कि मैं किसको काटूं, उधर ये वाली काटूं, and मुझे क्या करना पड़ेगा. This is very critical, right? So we understand this is very critical. So we have a critical decision making. या आपको और गाड़ी चल रही है ऑटो पायलट पे जो खुद चल रही है, ओके, अनमैन ना, या आपका ड्रोन चल रहा है, या आपकी गाड़ी चल रही है अनमैन. जैसे आप अमेरिका में जाओगे, बहुत सारी स्टेट्स वहां पर है, वहां कैब्स आती हैं विदाउट ड्राइवर्स. आप कैब बुक किया, वो गाड़ी आएगी, उसमें कोई ड्राइवर नहीं होगा, ठीक है ना. एंड दे हैव टू टेक वेरी क्रिटिकल डिसीजन कि मुझे यहां से जाना है कि यहां से जाना है, रुकना है कि नहीं रुकना है. एट द एंड ऑफ दिस क्लास वी विल मेक ए वन रोबो कार which will actually we'll create that robo car, right, using Raspberry Pi or maybe Arduino will do that. Raspberry Pi में भी हम काम करेंगे कि वो इवेड करेगी ना, ये अगर कोई आगे आ गया, it will make the way कि यहाँ से रास्ता नहीं है, यहाँ से जाएगी, यहाँ से रास्ता नहीं, यहाँ से जाएगी. The robo car will be built at the end. Okay, now you have to do all these things. So ये जो critical वाला मसला है ना, इस पे थोड़ा सा हमें और रिफाइन करना पड़ेगा, जो क्रिटिकल वाला मसला है इस पे सोचो जरा, अभी इस स्लाइड के बाद हम करेंगे। तो पहले जो हमें हमें स्केलेबिलिटी चाहिए कि डिवाइसेस बढ़ते जा रहे हैं ना, तो रिसोर्सेज बहुत ज्यादा आ रहे हैं एंड डेटा मोबिलिटी और बाकी सारी चीजें हैं, सिक्योरिटी के इश्यूज हैं, ये सारे इश्यूज हम डील करने वाले हैं, ठीक है। तो अब इसमें जो इंपॉर्टेंट चीज है कि भैया आपको, जैसे अभी अभी ये गाड़ी है अनमैन्ड कार, राइट, इज गोइंग, सो एआई ड्रिवन कार ये है आपके पास, इसको अभी रास्ते में कुत्ता आ गया, बच्चा अचानक से आ गया, अब इसके सेंसर जो क्लाउड बोल रहा है, क्लाउड क्या बोल रहा है कि आपने डेटा ले लिया एंड सेंड इट टू द क्लाउड फॉर कंप्यूटेशन, क्योंकि आपके पास तो कंप्यूटेशन उतना है नहीं, सिंपल प्रोसेसर्स है, ठीक है। तो कंप्यूटेशन के लिए कहां भेजोगे, क्लाउड में, यूजिंग इंटरनेट। समटाइम्स यू नो इंटरनेट stops or sometimes some glitch happen and there are some this called latency, this called what, टाइम लगता है ना भेजने में। जब ये भेजेगा वो सर्वर कहाँ पे होगा, वहां पे आ जाएगा, उसके बाद उसकी एनालिटिक्स होगा, उसके बाद वो भेजेगा वो ब्रेक मार कि वही वहां पे बच्चा है, तब तक तो वो चढ़ गई होगी गाड़ी, है ना। सो वी आर सेइंग दैट वेट, वी कैन नॉट हैव सच अ लेटेंसी इन क्रिटिकल सिचुएशंस, सो वी आर ब्रेकिंग दिस क्लाउड ऑन 3 levels। वी आर ब्रेकिंग क्लाउड इन व्हाट, आको शबनम, क्या को ब्यागो फॉग and Byago cloud. So we are dividing into 3 things actually. We are dividing what? Argo cloud, Byago fog, दूसरा क्या है fog, and तीसरा है शबनम किधर होता है, जमीन के ऊपर, that we call is edge. We don't say it शबनम because because अंग्रेज लोग don't say it like that, okay? They called edge, they called what? मगर हमारे लिए शबनम है, ठीक है, प्यारी सी शबनम जो कि वहां पे होती है नीचे। सो द शबनम विच इज कॉल्ड एज द एज एंड द फॉग एंड द क्लाउड। सो किधर है शबनम, सो ये यानी कि ये आपका एज है और बीच में आपका, और ये आपका, ये सारा इसी पे है जो क्रिटिकल आपको डिसीजंस लेने हैं ना। हम सोचते हैं कि अगर हम, ये बंदा, ये आईओटी डिवाइस है, ये आईओटी डिवाइस भेजेगा क्लाउड को, जब तक वापस आएगा ना तब तक तो जान गई होगी, ठीक है, और फिर जेल भी हम जा चुके होंगे। सो वी से नो लेटेंसी, लेट्स हैव सम कंप्यूटेशन पावर डाउन। इफ वी हैव द कंप्यूटेशन पावर क्लोजर टू द डिवाइस, ऑन द एज ऑफ द डिवाइस, इट्स कॉल्ड एज, ओके। देखिएगा हम क्यों इसमें और भी डिवाइड कर रहे हैं। एक तो हो गया कि वी वांट कंपटीशन, वी विल एंड विद दिस लेक्चर विद दिस, बिकॉज इफ यू डोंट डिस्कस दिस देन फिर ये फायदा नहीं है हमारे लेक्चर का, ठीक है। तो 2 दिन से जो हम काम कर रहे हैं वो इसी पे काम कर रहे हैं असल में। तो लेट्स हैव अ 5 minutes total attention with me, because when you go out you should have a clear understanding between cloud, fog and edge. Is that a promise? Okay, so what I am saying is, because if anybody is tired it is me, not you, because I am talking now, what you are listening only. So what I am saying is कि एक चीज ये है कि फॉर एग्जाम्पल हमारे पास एक हेल्थ मॉनिटर है, पेशेंट है, इसको लगे हैं डिवाइसेस, इट इज सेंडिंग ऑल द हेल्थ डिटेल्स ऑन द क्लाउड। अब बीपी मेजर कर रहा है, बीपी आ रहा है फॉर एग्जाम्पल इसका बराबर आ रहा है, ठीक है, कितना होता है 120/80, 120/80 आ रहा है या कुछ आ रहा है। अबे बार बार 120/80 120/80, क्योंकि सेंसर भेज रहा है ना 120/80 120/80, ये करोड़ बार भेजेगा 120/80, वो क्लाउड में चला जाएगा भाई। 120/80 वो बोल रहे हैं कि क्यों स्टोर कर रहा है इतना डेटा, जाया कर रहा है, ये तो पता ही है ना। तो अगर कंपटीशन हो, नो, so there are 2 things, there are what, out there are 2 things, what, there are how many, one is if we have to take critical decision, if we take what, number 1 if we have to take critical decision, for example बंदे को एकदम हार्ट रेट बहुत ज्यादा हो गई, सो हार्ट अटैक होने का खतरा है, ब्रेन हेमरेज होने का खतरा है, सो वी हैव टू हैव अ प्रोटोकॉल्स कि हमें क्या करना चाहिए, डॉक्टर को बुलाना चाहिए या कोई मैशिंग करनी चाहिए या कुछ इंजेक्शन इसको देना चाहिए, दैट इज बी टेकन वेरी क्विक इन अ फ्रैक्शन ऑफ अ सेकंड। अगर हम वेट करेंगे मर जाएगा, ठीक है। सो वी कैन नॉट वेट फॉर द क्लाउड, नंबर 1, ठीक है। सो वी हैव टू हैव इंटेलिजेंस देयर। नंबर 2, दैट फजूल में डेटा जा रहा है, अरे भाई जब थ्रेश होल्ड की, हमने कोई थ्रेश होल्ड रखा है रीडिंग का, अगर इससे बहुत ज्यादा चला गया, इससे कम चला गया, तब जाके भेजो ना, ठीक है। तो अब बार बार वो सेम ही क्यों भेज रहे हो, तो फजूल में वहां पे फजूल में जगह जा रही है ना। So we want to take decisions. So there are two scenarios here. One, we have a critical decision. AI कार जा रही है, अचानक से बंदा आ गया वहां से बच्चा. So he has to maneuver. This decision has to be taken a fraction of a second and there only. We cannot wait for any latency. There is no chance. ठीक है ना? Because नजर हटी तो दुर्घटना घटी. So we don't want to have that. So we have some intelligence close to the device. That's called edge. That's called what? If we are putting some processing power and decision making, we have some AI. It could be in terms of software and hardware also, which will take the decision closer to the sensor. That is called which will take me the critical decisions. Which will take me what? कि हार्ट अटैक होने को है तो ये कुछ इंजेक्शन वगैरह या डॉक्टर कॉल या कुछ करना है, अलार्म बजाएगा, जल्दी से हो जाएगा वो. ठीक है. और दूसरा होता है फॉग. फॉग कहां पे है? बीच में इन दोनों के. तो फॉग जैसे एक गाड़ी जा रही है, सिंपल एक गाड़ी जा रही है, कि जो एज कंप्यूटिंग होगी वो क्या करेगी काम, वो स्टीयरिंग को देखेगी. किसको? जो इमीडिएट डिसीजंस है कि एक्सीलरेटर दबाना है कि ये करना है कि क्या करना है मेरे को, है ना. और जो फॉग कंप्यूटिंग है वो क्लाउड और एज के बीच में है. फॉर एग्जाम्पल इज मॉनिटरिंग द ट्रैफिक ओवर द ब्रिजेस एंड ऑल. इट इज अगेन टेकिंग इमीडिएट डिसीजन कि भाई मेरे को इस रूट नहीं लेना, ये रूट लेना चाहिए, यहाँ पे बिजी रोड है. ठीक है. दैट इज डन बाय द फॉग कंप्यूटिंग. दैट्स डन बाय व्हाट? वो डेटा एनालिटिक्स, क्योंकि मेरा सेंसर तो भेज रहा है ना डेटा, तो फॉग कंप्यूटिंग जो है ना वो यहाँ पे बैठा है ऊपर, वो मानो आगे का देख रहा है ये. ठीक है. एंड क्लाउड कंप्यूटिंग पे जब हम जाते हैं वो लॉन्ग टर्म हम डेटा जो उसको भेजेंगे हम, और फॉग कंप्यूटिंग करते हैं वो फिल्टर करता है डेटा को कि क्या भेजना चाहिए क्या नहीं भेजना चाहिए. यार बीपी भेज रहे हो, बार बार बीपी जा रहा है और फॉग देख रहे हैं तो सेम ही बीपी है, मत भेजो. एक बार मैंने भेजा है 120 पे 80, अब मत भेजो. ठीक है. जो ही थ्रेशोल्ड के ऊपर चला गया, अब फॉग डिसाइड करेगा नहीं मेरे को भेजना चाहिए क्लाउड को, ताकि वो एनालिटिक्स, क्लाउड अपनी एनालिटिक्स करेगा कि लॉन्ग टर्म दिखेगा कि इस पेशेंट की हालत क्या है, इसकी सिचुएशन हमें क्या सिनेरियो करना चाहिए. गेटिंग क्लियर? सो वेयर इज फॉग? इट इज बिटवीन द cloud and edge. It filters the data, it takes some decisions which are again immediate but not that critical, and edge is where it's closer to the device and it takes the critical decision. And the cloud तो फिर हमारे पास है ही for long term analytics. Getting? Everybody got it clearly? Any questions? That's yes. तीनों करेंगे ना. We will do all the three. We will do what? Cloud जो IoT हमारा होगा इसमें all the three होंगे. ठीक है? You getting my point? But sometimes we only use cloud if we do not have a critical operation to be done. अगर हेल्थ आपको मेजर कर रहे हो कि इसमें पता है क्रिटिकल डिसीजंस है, ठीक है. अगर कोई नॉर्मल सा काम हम कर रहे हैं IoT के जरिए तो उसमें क्रिटिकल डिसीजन लेने की उतनी जरूरत नहीं है. Then we can skip the edge and that thing, right? But if we have the critical decisions to be taken, we have to take care of these things. So overall हमारे IoT में तीनों कंप्यूटिंग्स होंगी, cloud, edge computing and when you say edge computing, when you say computing, it is having the processor, it is having the computers, they will do the computing, right? But overall it's all distributed computing. Got it? Give it a tap.